Hi friends, in this video I am going to tell you top 100 MCQs of reinforced cement concrete design. So before going ahead, please make sure to subscribe our channel Civil Engineering World for the future videos and lectures. Okay friends, so this video covers top 100 MCQs for test and also for interviews. So let's get started. Also make sure to subscribe and share this video with your friends. Okay, let's get started. So first one, the neutral axis of balance section is called. This answer is critical neutral axis. Okay, let's move to the second. The spacing of vertical stirrups in rectangular beam is minimum near the supports. B is the correct answer. Next is partial safety factor for concrete and steel are 1.5 and 1.15 respectively, because B is the correct answer. The control on the quality of concrete is not good as that of steel. Next is the bond between the steel and concrete is mainly due to. So this is due to all of these, also adhesive, frictional and mechanical. So we will select D. D is the right answer. Next is the reinforced concrete slab is 75 mm thick and the maximum size of reinforcement bar that can be used is off. So for this purpose we have to go for a table that we have. So here the diameter of bars shall not exceed 1/8 of the total thickness. So we have the thickness of slab is 75 mm, so our answer is 9.37 mm. So its answer will be approximately about 8 mm, right? So its correct answer will be 75 divided by 8, which is 9.3. So the correct answer is 8 mm diameter. Okay, next move. Shear reinforcement is provided in the form of. So we provide shear reinforcement also in vertical bars, in line bars, and all of these. Or we can say D is the correct answer. Or it may be combination. So next is RC beam is subjected to the following bending moment. Dead load is given 20 kN, live load 30 kN, seismic load 10 kN, and we have to calculate the design bending moment. So for this we have to find this table and formula. So for a maximum ultimate bending moment, we will use the formula 1.5 dead load plus live load. So by putting these values, 1.5 into 20 plus 30. So answer comes as 75 kilonewton per meter. So this is the ultimate bending moment. So also for seismic load, we can calculate 45 kilonewton per meter, and also for dead load, live and seismic load, we can use both formulas, and its answer is 72 kilonewton per meter. So now we are asked the question that ultimate bending moment, whichever is greater, which is the design bending moment, which is 75 kilonewton meter. So in all of these we have to select 75 kilonewton meter. Next is the maximum depth of the neutral axis for a beam with D effective depth in limit state method for design of FE 415 steel is. So for grade 415 steel we have to calculate limiting value of depth. So for 415 we have value 0.48 D. So this is the limiting value of depth of the neutral axis. So for different grades we have different values. So B is the correct answer. So next is doubly reinforced beams are recommended when. So its answer is when beam is restricted depth. A is the correct answer. Next is in cantilever beam carrying gravity load main reinforcement is provided. Its answer will be above the neutral axis. A is the correct answer. Next is usually stiffness of simply supported beam is satisfied if the ratio of its span to depth ratio does not exceed which one of the following. So for this we have a table. We will consult the table for the given options and answers. So stiffness is defined as the property of materials which gives the rigidity and tells us the difficulty to bend. So for cantilever, its ratio should be 7, and for simply supported its ratio should be 20, and for continuous its ratio should be 26. So we have a simply supported beam, so its answer will be C, 20. Okay. So next is in singly reinforced beam, maximum compressive stress in concrete and tensile stress reach the permissible stresses simultaneously. What is the section is called? So this is called balance section, where both stresses reach simultaneously and at the same time. So its answer will be C. C will be its answer. Okay, so next is next move to the next one. In this one, what shall be the maximum area of reinforcement in compression and tension in RCC beams? So normally we use the formula that is 0.04 of B into H. So B or D. So its value will be 4% and 4%. D is the correct answer. Okay, next is how is the deflection RC beam is controlled? So it totally depends on span to depth ratio. So C is the correct answer. Next is what is the adoptable maximum spacing between vertical stirrups of RCC beam of rectangular cross section having effective depth of 300 mm. So we have to calculate the spacing. So for that we have the formula 0.75 times depth. So here depth is 300, so multiplying it we get 225 mm. So the minimum of this is selected, so its value is 225. It should not exceed 300 mm. So its answer will be 225 mm will be the correct answer, and this is the minimum spacing that we can provide between the members. So D is the correct answer. Next is what is the modular ratio to be used in the analysis of RCC beams using working stress method if the grade of concrete is M20? So for this we have this table. We have to calculate the modular ratio M and 280 over 3 into sigma CBC. Sigma CBC for M20 concrete, we have this table. For this is the permissible compressive strength. For M20 we have 7 Newton per millimeter square. So we can put this permissible compressive strength value into the formula. So we have different values of compressive stress permissible values for different grades. So by putting this value we have modular ratio that comes to 80 over 3 into times 7 is 13.3. So its answer will be 13.3. B is correct. Next is in RCC beams, as per percentage area of tensile steel increases, A, depth of neutral axis increases. Next is the span to depth ratio limit is specified for the RC beams in order to ensure that. So in this case, this span to depth ratio is limited in RCC beams just because this is due to the deflection of the beam, so that it should be less than limiting value. D is the correct answer. Next is the limiting value of depth of neutral axis in a reinforced concrete beam of depth D is given by. So its answer can be anyone, because it is not given that it is singly or doubly reinforced. So we have to select the for this we have this table. For grade 250 we have different values. If the permissible stress is in steel and tension is 440 Newton per millimeter, then the depth of neutral balance section using working stress method is. So we have this table, we have this balanced neutral action section. By using this formula we have depth is not given, but grade is given for 140. By putting these values we can get 0.4D. So sigma st is the permissible stresses which is given, which is 140. So its answer is B, 0.40. Next is the concrete beam is deemed to deep beam when the ratio of effective depth to the overall depth is less than, so its answer will be 2.5 C. Next is in doubly reinforced section beams, the allowable stress in compression steel is less than the permissible stresses in tension. C is the correct answer. Okay, so next move, the lever arm in the singly reinforced beams is equal to, so its answer value is d minus n over 3. If we just take its LCM, it will be 3d minus n over 3. So here C is the correct answer. Okay, so next please, the side face reinforcement if required in T-beam will be, so its value will be 0.1%. Next is D beams are designed for, they are both for bending moment. Okay, the minimum clear cover into the main steel bars, beam, column and footing will be B, 15, 25, 40 and 75 millimeter for slab beam, column and footing. Okay, so next is beam sections are designed in accordance with LSM, and as compared to WSM will have smaller depth and same reinforcement and small reinforcement. Okay, so C is the correct answer. If the depth of the actual neutral axis in the beam is more than the depth of the critical neutral axis, then the beam is called over reinforced beam. So you have to make the difference between different beams, whether it is balanced, under or over. Okay, so in our case it is C. For a continuous slab of 3 into 3.5 meter size, the minimum overall depth of the slab to satisfy the vertical deflection limits is, so we have this formula, length or depth should be less than 28 for simply supported and should be less than 32 for continuous. So we will use this formula as we have a given span length. We convert it into millimeter. 3 is the shortest span, so convert it into millimeter, which is 3000 millimeter. 3000 or D should be less than 32, so here D should be less than or equal to 10 centimeter. So in our case it should be 10 centimeter, right? Okay, so let's go to the next. The minimum reinforcement using mild steel in slab should not be less than, so its answer will be 0.15%. C is the correct answer. So it varies depending upon the steel grade. Okay, so let's move to the next one, which is it totally depends on YSD. Okay, so in the reinforced concrete slab, the spacing between main reinforcement should not exceed, so it should not exceed minimum of 3 times of its effective depth. So we have this table, horizontal distance between the main bars should be least of the following, or 3D or 300 mm. So here we will take 3D, which is less. So lever arm constant is determined by, so here we have the formula, we can use it, 1 minus K over 3. B is the correct answer. Flexural collapse in over reinforced beam is due to, so for over, this is due to tension failure. Spacing of shear stirrups is, in a rectangular RCC beam is, for rectangular RCC beam is, here we have to find, so spacing of shear stirrups is increased at the location where shear force is less. So as we go towards center, we actually decrease we increase the spacing, and as we move towards column, we have to increase the spacing. So for this case, it is D is the correct answer. Okay, so let's move to the next one, which is permissible stress. Shear stress in concrete is a function of, so grade of concrete, grade of steel, percentage of steel and percentage of steel. So D is the correct answer. The slab is designed as one way if the ratio of the longer to the shorter span is greater than 2. B is the correct answer. Okay, so here we have formula longer to shorter. If it's greater than 2, then it is one way, and if it's less than 2, it is two way. Even if it is equal to 2, it is also one way slab. Okay, so here we have already found that B is the answer. So next, the minimum grade of concrete for hydraulic structure as per IS code is M30. So for RCC structures it is M20. So next is the half of the main steel in simply supported slab is bent up near the support at the distance x from the center of the slab, bearing where x is equal to 1/3. For example, if we have a span of 30 meter, then of course we have to divide off, or if we have a span of 7 meter, and then we have to divide it by 7, then it means that we have to bend the steel from 1 meter. So C is the correct answer. So for 39, a characteristic load is given by F is equal to Fm plus 1.64 S. So B is the correct answer. Okay, so due to shrinkage stresses, a simply supported beam having reinforcement only at bottoms tend to deflect downward. A is the correct answer. Next is percentage of steel for balanced design of singly reinforced section by LSM totally depends on all of these. D is the correct answer. Okay, so let's move to the next one. So we have the next one, the neutral axis in the T-beam section falls in. So we have either A or B, because sometimes it may be inside the flange or outside. So it really depends on the type of stresses. So it may be inside the flange or outside the flange. So we have the answer C. Next, the T-beam behaves like rectangular beams of width equal to its flange if neutral axis remains within the flange. So B is the correct answer. Okay, so let's move to the next one, which is the splicing of reinforcement bars in RC beams can be done at this section where the bending moment is less than 1/2 of its maximum bending moment. C is the correct answer. Okay, so let's move to the next one. When the vertical member is carrying mainly axial load, it is termed as column. So when it is inclined, it is called strut. Remember it. The relationship between stress-strain distributions in concrete is assumed to be parabolic. C is the correct answer. So there are RCC beams under the mild exposure conditions having the longitudinal steel reinforcement of 12 mm dia and minimum allowable nominal cover should be. So for this we have a table. We are going to consult it. For mild conditions we can take the nominal concrete cover, which is 20 millimeter, but here we have a condition number 1 for main reinforcement up to 12 mm diameter. For mild exposures, the nominal cover may be reduced by 5 mm. So it means that we have to reduce it by 5. So after that, we will get 15 mm. So for mild conditions, we have 15 mm. B is the correct answer. Okay, so for 12 diameter, we have selected to a 15 mm diameter, right? Okay. So let's move to the next one, which is 48. For the next one, we have another condition for exposure conditions. If it is of concrete M35 for very severe, we have to reduce it by 5. So this is for your additional information. You can use it. Okay. So for next one, the width of the flange of L beam is taken as. So this is the minimum of all of above. So our answer is D, minimum value of A, B, or C. So it depends that whichever value is smaller of all of the above. The 49 is which of the following statements are correct? Lesser depth compared to the design by WSM, higher value of steel compared to design by working stress method, lower cost compared to design by WSM. So here we have select both B and C. D is the correct. For the reinforced concrete section, the shape of shear stress diagram. So this is actually parabolic above the neutral axis and rectangular below the neutral axis. So C is the correct answer for this. Okay, so now we have covered 50 MCQs. Now let's move to the next 51. Also, please make sure to subscribe our channel. Okay, so next 51 is the ratio of permissible stress in LSM of design and WSM of design is. So we have to calculate. It is we have formula of limit state method design, we have 0.45, and in working state we have 0.16. So it comes 25/16, which means 5:4. So it means A is the correct answer. So the contribution of bent up bars towards the shear resistance shall not exceed more than 50% of total shear reinforcement. So answer A is the correct. Okay, so lever arm is the distance between the center of the tensile zone and the bottommost. So here C is the correct answer. Here you can see this is the compressive resultant and this is the tensile resultant. So a lever arm is the distance between the compressive resultant and tensile. Okay, so the minimum cover in the slab should neither be less than the diameter of bar nor less than. So the minimum cover in the slab having the diameter which should be not less than 10 millimeter. So we can also calculate it by 15 millimeter. So the minimum cover in the slab should neither be less than the diameter of bar, which is B. The average permissible stress in bond for plain bar tension is the permissible stresses, which is decreased by 10% for bars. So we have this formula. The bond stresses shall be increased by 25% for bars in compression, and it is increased by 60% for deformed bars. So we have this formula we can use. Here we are given this formula. If we have the stress of 1 kilonewton, then it is increased by 1.25, and for those deformed bars it is increased by 1.60 kilonewton. It means that for deformed bars, if there is 1 kilonewton stress, then we will take or increase it by 1.60. So B is the correct answer, which is increased by 25%. Okay, so when the shear stress exceeds the permissible stress in slab, then it is reduced by increasing the depth. A is the correct answer. Okay, the unit weight of PCC is 24 kilonewton per meter cube. B is the correct answer. So for RCC it is 25. You should remember it. So next is for M20 grade of concrete, the maximum shear stress shall not be. So we have a table for M20 grade. It should not be greater than 2.8 Newton per millimeter square. So as the grade increases, it also changes. So C is the correct answer. In the reinforced concrete retaining wall, the shear key is provided. So this is actually due to against sliding. So for example, shear key has two functions. It is to reduce the wall sliding, and its second function is to resist lateral load due to seismic force or the earthquake. So its function is to reduce sliding. So C is the correct answer. Okay, so next one MCQs is which method is referred to be as deterministic. So working stress method is deterministic because we as not only assume loads, but we also calculate it properly. That is also called accurate. But while limit state method is non-deterministic because it is based on experience in field data. So working stress method is deterministic, right? A is the correct answer. How we can how the shear strength can be ensured in the beam. So B is the correct answer. Shear reinforcement is provided to resist diagonal tension. D is the correct answer. Okay, so let's move to the next one, which is shear reinforcement. The deep continuous beam has an effective depth of 500 mm and effective cover of 50 mm. Its maximum effective length is, so we have this formula. length or depth should be less than 2.5. So length shouldn't be less than 2.5 into d. So here we have to add this effective cover 50 mm in its total depth, which is 550 mm. So by multiplying these two values and after adding, so 500 plus 50 is 550. So 2.5 times 550 is 1375 mm. So 1375 mm is the answer. When HYSD bars are used in place of mild steel bars, then its bond strength increases. B is the correct answer because these bars increases the bond strength between concrete and also steel, because it is shaped in such a way so that it should increase the bond strength between the concrete and the steel. So B is the correct answer. Okay, so what is the bond stress acting parallel to the reinforcement on the interface between bars and concrete? That is called shear stress. So A is the correct answer because there is the shear force that acts. What is the Anchorage value of the standard hook of reinforcement bars of diameter D? So here we have this table. Here you can see its standard hook length should be 16 times of its diameter of the steel bar. Okay, so 16 times of its diameter is the correct answer, but in case of 90-degree, here we have formula which is 8 times. So here 16 dd is the correct answer. Okay, the bond strength between the steel and the concrete is due to both friction and adhesion. So C is the correct answer. Okay, the process of providing a suitable lap of bars over one another to develop full length or strength is called C is the correct answer, slab splice. So this is also called splice length, which is where we have to uh, connect two bars, right? So C is the correct answer. Lap splice shall be considered as staggered if the center to center distance is not less than. So if it is not less than 1.3 times lap length, then it means that lap splice is considered as a staggered. So here B will be the correct answer. Okay. So the bond strength between the steel and the reinforcement and concrete is affected by steel properties, concrete properties, and shrinkage. Both, all of above is the correct answer. D. Okay, so bond strength can be enhanced when high-grade concrete is used, small diameter bars, deformed bars, all of above. So D is the correct answer. All of above means all factors contribute towards bond strength. So if the RC beams fails in bond, the bond strength can be increased by. So the bond strength B is the correct answer. Use thinner balls but increase their numbers. Okay. So we are gonna jump to the next one, which is twisted bar has how much more yield stress than ordinary mild stress bar? So it has 50% more. D is the correct answer. Okay, so in a singly reinforced beam, the effective depth is measured from the compression edge to the so this is the singly reinforced, so this is the center of the tensile reinforcement. B is the correct answer. So the maximum spacing of vertical reinforcement in our reinforced concrete should not be exceeds than 3 times. So here we have the maximum spacing should not be greater than 450 mm, or it should be less of 3T or 450. So here whichever is less is used. So 3T, in this case we have our thickness, so D is the correct answer. Okay, so the tensile strength of concrete is about what percentage of compressive strength? 10 to 15%. So A is the correct answer. Okay, so let's go ahead. The next, reinforcement concrete beam will crack if the tensile stress of concrete is. Of course, B is the correct answer. If it is more than permissible stress, then the reinforced concrete beam will crack. Okay. Bond between steel and concrete can be increased by using HYSD bars, because these are uh, treated bars and it increases the bond strength. Okay, so here we have three options, so D is the correct answer. Sorry, adopting all of the above steps. Okay, so minimum length of the bar which must be embedded in concrete to develop its full strength is called development length, right? This is B is the correct answer. So next, near the midspan the cracks are. So here we have different types of cracks. So we are just talking about the center of the beam. So here we have different types of cracks that are purely vertical at 90°. Then if we just go towards the supports, then they are perfectly inclined at 45°. Then at any distance between these is maybe 60°, both inclined and also vertical. So here we have purely vertical cracks at center, and here we have both 45 and 90° cracks between these. Okay, so here we have vertical cracks. C is the correct answer. Okay, so next one is, we are gonna go to the next one. In reinforced concrete beams, the shear stress distribution above the neutral axis follows so we already discussed its answer is C, parabolic line, because it is above the neutral axis. Okay, now go ahead and what should be the bearing of beam on brick walls for span up to 3.5 meter? So here we have table, we are gonna check it out. For span up to 3.5 meter, we have to use 200 mm bearings. For 5.5 we have to use 300, and for 7 meter span, so here's answer is A. Okay, so side face reinforcement in beams or deep beams is equal to 0.1%. C is the correct answer. Diagonal reinforcement tension in concrete can be resisted by providing diagonal tension reinforcement. A. The strength of concrete after 28 days is about 10% of the strength of concrete. Sorry, 80%. 80% of the strength of concrete. C is the correct answer. Okay. It means that 80% of concrete strength can be achieved in 28 days as compared of its 1 year. So C will be the correct answer in our case. Okay, so let's go ahead. A minimum grade of concrete for post-tension pre-stress concrete is M30. Okay, so for longitudinal shearing stresses acting on the surface between steel and concrete is called bond stresses, because these are bond stresses that actually comes in contact between the surface of reinforcement and also concrete that prevents slipping of concrete. Okay, so this is bond stress. Okay, it depends on grade and type of the steel. Okay, so A is the correct answer. The minimum compressive strength of 33 grade OPC is 33 Newton per millimeter square. B is the correct answer. Okay, so let's go ahead. And in India, volume of cement bag in liter is 35. So we can calculate it. We have for 50 kg bag of cement, we will use formula mass or density. So mass is 50 kg, density of cement 1440. That comes 0.3472 meter cube. As we have liter, in order to convert it into liter, we will multiply it with 1000, and answer comes as 34.72 if we round it. So it is 35 liters. So it means that B is correct answer. Okay, so next one, characteristic strength has -% reliability. D is the correct answer, because characteristic strength has 95% reliability. Okay, so let's go to the next one. When an inclined horizontal member is carrying mainly axial load, it is termed as, so remember it is inclined, so it is called strut. B is the correct answer because it is not vertical, it is inclined or horizontal. So B is the correct answer. Okay, so the diameter of longitudinal bars in column should not be less than 12 millimeter. C is the correct answer. In this case, the maximum strain in the concrete at the outermost compression fiber is taken as 0.0035 C. Okay, the design compressive strength in concrete in limit state of collapse in bending is, of course, you can divide it 0.67 by 1.5. That comes 0.45 FCK. Okay, so here we have C is the correct answer. Next one is the section of beam having greater width at the top of the compression to the width below the neutral axis, that is called not critical section, that is called T section. So here we have a T section. It says that okay, so in the T-beam, the breadth of the rib is equal to width of the portion of the beam in tensile zone. C is the correct answer. Okay, so the section in T-beams, we are gonna see another question that I already told you. If I say that question was, this was a T-beam and this is its rib, its width is saying that how much it should be. Okay, so in the T-beam, the breadth of the rib is equal to the width of the beam in tensile zone. Okay, so the next one is the breadth of rib in T-beam should be at least be equal to the dash the depth of the rib. So it should be minimum of 1/3. B is the correct answer. So next one is we are gonna go to our last MCQs. In the T-beams, the vertical distance between the bottom of the flange and the center of the tensile reinforcement is known as we have breadth of flange, thickness of flange, breadth of slab, and depth. So depth of rib is the correct answer. D. Effective depth of the T-beam is the distance between top of the flange to the center of the tensile reinforcement. B is the correct answer. So here we go for last MCQs. When the T-beam is continuous, the assumed overall depth of the beam for heavy load is. So here we have table. We are going to consult it for different span lengths. So for simply supported, it should be between 1/12 to 1/15. So for continuous beams, for light loads is this, and for heavy loads we can take 1/10 to 1/12. So for medium we have 1/12 to 15. So we are going to take 1/10 to 1/12. So A is the correct answer. So guys, these were the 100 MCQs that we have made. So we have also made other MCQs of other books like surveying, fluid mechanics, environmental engineering. Please go ahead and check out these videos. Also, don't forget to subscribe our channel for future videos. Thanks for watching.